Hello, in this video I was going to cover some general updates for my non-invasive glucometer project. If you're not familiar with this project, I'll put a link to the original video I did on it, describing it in more detail in the description. And you can also just go to the GitHub page, github.com/knowthebird/non-invasive glucometer, and you can see more details in the README there. Essentially what it is a project to look into open source, open hardware, non-invasive glucometers people can use and share that information to try to sort of advance that. But from a hobby perspective too, this isn't professional research. I'm not a medical doctor, not a medical researcher or anything like that, just sort of hobby level. Originally there was a contest I had set up. The idea with the contest was that it might, encourage some competition and some new ideas and, getting a little more people to join in. Sadly, there weren't any contest entries, so I'm just going to set aside the sort of money I'd put for prizes and hold on to it for different, for the non-invasive glucometer projects. And if you're interested and you have an idea and you could use a little bit of cash to help you get started on it, you can reach out to me too, and maybe I can help you with it, or we could figure something out there. noninvasiveglucometer@gmail.com. There were people who reached out with interest in how the things were designed and had suggestions for improvements and future designs, and that was super helpful, and I did appreciate all that, and hopefully there'll be more communication like that in the future. The next design I have for another portable non-invasive glucometer is very, very, very heavily influenced by conversations with people that reached out. So I think that'll be good. And just because there wasn't entries in the contest does not mean there's not interest in this problem. There's actually a ton of interest in this problem, both commercially and academic. And I'll follow back up with that at the end. But yeah, just because they're not, and I think that's because a lot of them are also trying to look to protect their intellectual property and not necessarily interested or even aware of this random contest. So I'm not too discouraged by that. I did get a lot of new log data recently. So I want to say thank you, Dave. Dave provided a friend of mine, Dave, provided a ton of data with a very wide range, about 90 samples on 2 separate fingers with a very wide range of concentrations from 76 to 447 milligrams per deciliter. You can see up here on the right is the sort of the range of the data there. One of the issues I had before when I was testing it, the first design, was that I wasn't sure if the inaccuracies I was seeing was just due to the range of the data, that if I had a wider range of data, I might see more correlations with the blood glucose concentrations. Sadly, with this new data, I know that's not the case, but that new data did prove that and some other issues. So it is certainly helpful to have. The expected results were that as the blood glucose concentration increases, more light is absorbed by the glucose, and both reflectance and transmittance sensors are going to report less light. So it gets absorbed by the glucose and it doesn't leave, so the sensors are going to see less light. And for this particular design, less light to the sensors results in a higher voltage. So with this design and this microcontroller at 12-bit resolution, so a peak of 3 volts gives you a reading of about 4096, and 0 volts is 0. So when we're looking at the results, a higher number should mean a higher blood glucose concentration. And that's not what I saw. So this isn't all the data. This was sort of spot checking a few points. But what you can see is that as the concentration goes up from what are we, about 70, 80 milligrams per deciliter here, all the way up to 350, we don't see a significant change in the readings on the sensor. And you can see they sort of go back and forth, up and down, and that's definitely not what I expected, and suggests there's things that I need to fix with the design. One of the big things I saw when I started looking at the data is it looks like there was a hardware failure. You can see here that you can see these different PPG waveforms, and there should only be one of these. So when you start plotting the data, you can actually see it looks like this is getting mirrored or duplicated and shifted. It seems to be in just about every single log. In some files, it almost seems like it toggles on and off right here. I don't think it's actually toggling on and off. I think it is still present in these signals here. But what you can see is that the separation of the two, dramatically increases at this point. And there's no software calls that are happening at this point. There's no like software logic or new method that's being called, which is part of the reason I think it is a hardware failure. And because this isn't consistent through them, it's sort of a random point where this happens. You can see the same thing happens here at different points, and this doesn't typically happen, but you can also see here, it almost looks like one signal, but you can see there's a little gap there, and there's actually, this is being duplicated also. If you were to zoom in on that, that would be easier to see. But yeah, so we're seeing that data get split up, and I mean, long story short, there is that looks like a hardware failure to me. And in some cases, it's not even just a duplicate of the signal. It's I don't know. I don't know what happened here. This looks like it just died. That looks like a serious issue going on with it. On some of these, though, where the data was duplicated, let me see if I've got a good example. I guess I don't have a good example, but on some of these, you could still open up these signals and zoom in closer and see a clear like PPG waveform. Like on these ones here, you could zoom in and see. On some of them, you couldn't. So that was sort of hit or miss. I would say on the majority of them, you could zoom in and typically see a waveform, though. So that's promising. I'm thinking there was probably some kind of coupling with the sensors. And maybe, either a short between the sensor readings, or maybe they're just not insulated well enough from each other that somehow they started to couple. There were some other issues in the data I saw, some movement artifacts. So these are things just like the duplicate waveforms they're pretty easy to spot by eye when you're looking at the data. But if you're trying to automate processing the data and get averages and things like that, and you only want valid signals, it's not trivial to just you don't just throw that into Excel and tell it to pull out movement. So easy to spot by eye, but makes looking for valid signals more difficult for sure. And so this could just be this right here is not the heart rate changing. This is just a very slight movement in the finger, but results in a pretty big change. You can see in our readings from, what are we at here, 2700, and then up here we're closer to 2750. And currently there's no IMU to detect any sort of acceleration or changes or notify the user that, hey, this movement is causing an issue. So in hindsight, some lessons learned. Getting a variety of samples is not trivial. And the glucose concentrations typically stay in a set range, and extremes are a health risk. This is an extreme range of data there. That's not an easy range of data to get at all. Very wide range of data. And the hardware needs to be more reliable before sending out in the world. I do feel bad that there is a hardware failure with such a wide range of data. I think that I can look at the data close enough to tell that there's still other issues with the design, that even I can still get information even with this hardware failure, because the PPG signals are generally clear enough to see. I think that there's still some validity to them, and that I can still say that even without this hardware failure, I think we would have seen some of this general trend. But nonetheless, I wish I had tested it a little bit more and made sure it was a little more robust before sending it out into the world, for sure. And a way of sharing results remotely, like over Wi-Fi, could make it easier to identify issues faster. So I didn't realize that this data was actually getting corrupted until I got all 90 logs. So it might have been good if I'd checked in sooner, or if there was some way to like remotely transfer it, and I could be like, oh, looks like something's starting to go wrong there, or something like that. So that's some of the lessons learned in hindsight. So what do I think the next steps are? I think maybe I bought off or bit off a little bit more than I could chew with that first design. So I'm thinking that I need to look at measuring controlled samples in a controlled environment. So I was thinking maybe cuvette containing solution of dextrose monohydrate and distilled water. I saw that's what another person did in their project to first confirm their sensors were working. I think that's probably what I need to do too. Use a fixed position of emitters and sensors, and I could 3D print a jig to put those in, and make sure that the positions between them isn't variable like it is in the finger clamp I'm using now. And just use a PC oscilloscope for sampling that data. You probably don't need it just for an average voltage at first, but it will be having that oscilloscope will probably be helpful for recording like PPG waveforms, and if I ever look at doing some sort of like PPG feature extraction or machine learning algorithms with those kind of things, having nice clean waveforms will certainly be handy. And you can have high resolution samples to begin with, and then you can see, okay, how much can I downsample that and still get accurate results. And the oscilloscope, PC oscilloscope like COTS1 will have the built-in logging. Like one of the issues I saw with the microcontroller was that, when it saved data, it could affect the samples, and that you needed to give it a certain amount of time to write all the data before you could read again. So there were issues trying to sort of recreate that with a microcontroller that, at least for starting out, I could completely avoid. And I could also use test probes and consider covering the test setup to reduce any noise in the readings. So that would probably be helpful too. And I think that would just be really good to be like a sanity check of like, okay, is this sensor and emitter that I'm using going to work at all? Like if it doesn't work with a solution in a sort of lab setting, then it's certainly not going to, hold up once I start talking about trying to make a portable device with, different size fingers and people's different hydration levels and all the other things that are going to go into that. So yeah, I think that I should probably try to keep it simpler first and just confirm. And it'll be helpful for me too to sort of get an idea of what to expect with the sensor readings. So like how much of a voltage change should I expect to see when we have this much of a concentration difference. And then long-term improvements for a device. So a little bit further out, not just talking about like, okay, what's the next steps for testing, but in the long run, what are something we could do better? I'm thinking maybe fixed position for sensor and emitter. It'll certainly make the problem less complex when not accounting for their movement. I think it simplifies the problem a lot, and I'm not sure. I guess at this point right now with the data I'm saying, I'm kind of skeptical about how well I would be able to measure a concentration. It seems like if the sensors I'm using right now really are picking up on a concentration difference, it is completely overshadowed by movement and slight variations in finger position. And then another improvement I think would be IMUs on the device and our finger/ear for whatever the device is. I think that would be super helpful for identifying when there's been movement for either post-processing or for in real time notifying the user, hey, this is too much movement and is going to result in an invalid sample. So I think IMUs are definitely something I'd want to add. And even if you don't end up using, say you come up with a solution that seems really robust and you can tolerate some movement in the position of the sensor and emitter, you could have multiple IMUs, one with the sensor and one with the emitter, and actually use that to calculate the distance between the two, if you could work that into your equations for calculating the concentration. Maybe cover the sensor and emitter, some kind of bag, glove, or something else, especially if you used a fixed position sensor and emitter. Part of the reason of making a finger clamp that could move was to try to make sure there wasn't any sort of gaps for light to get in and sort of corrupt the sensor readings. And so if you don't have that, then maybe you need to look at ways to shroud that a little bit better. Other ways with, bag, glove, cover, something. I don't know. That's just sort of thinking out loud. And then very long term, consider the ability to share data through Wi-Fi or cell phone applications. I think that would be very nice to be able to get data as far as like gathering data quicker and sharing data and log data. I think that would be really nice, some sort of Wi-Fi interface or Bluetooth application for cell phones. I think it also adds a lot of complexity and security risks as far as like medical data goes. So it's not like a priority, but it's like once something's working and could be generally dispersed, I think that would be super handy. And I know one of the other persons I was talking to was definitely thought that one of the other advantages of it is if you're looking at different machine learning techniques, you can use Wi-Fi or Bluetooth to sort of just shove the data over to a cell phone and use that to do the processing. So you can put all the tough processing tasks to the cell phone and keep the device even much simpler, just basically sampling. And that can keep the price down too. So there's some advantages to it also. And then this is also something I wanted to share. This is from Amir Kakan. Hopefully I pronounced that right. But this is a list of different companies and universities that are actively doing research into non-invasive glucometers. I think he's also looking into designing another method of doing a non-invasive glucometer. I just sort of share this as this is certainly an active research topic. So even with my sort of list of speed bumps and issues that I run into, I just sort of want to share this as kind of like a positive, like there is a lot of research going into it, and there's actually a lot of papers still being published showing good results. So I think I need to sort of step back and simplify my little experiments to make a little progress at sort of stepping stones and build up on it. But I do want to share this too, is just like, it's definitely a very active field and something that we can probably look forward to seeing more commercial solutions in the next few years just available to the general public. There is a lot of research and development going into it right now. Yeah, so that's the big updates for my non-invasive glucometer project. Feel free to reach out to me via email or in the chat or in the comments. Yep, there's the Git repo. And my email is also available on there or here, noninvasiveglucometer@gmail.com. For any questions related to this, definitely reach out. Yeah, so thanks for watching. Take care.